Good morning. Today we're going to talk about subtraction of real numbers. This is section 1.7 in our text, and really an extension of addition of real numbers that we saw last time in section 1.6, right? All right, subtracting real numbers. We all know how to subtract numbers. 9 minus 4. Well, we all know what 9 minus 4 is. Our textbook does something like this, at least in the beginning, a little more formally than we might be used to. They say when you're subtracting a number from another, it's equivalent to adding the opposite. So we can say 9 minus 4 is equivalent to 9 plus negative 4, which of course is 5, right? All right, so hopefully not a big deal. Same thing. How about here? 4 minus 9. Then, well, if you're going to be formal about it, if you're subtracting a number, it's equivalent to adding the opposite. So 4 minus 9 is 4 plus negative 9. And when you add 4 to negative 9, you get a negative return of negative 5, right? How about minus 4 minus 2? Well, again, minus 4 minus 2 is equivalent to minus 4 plus negative 2. And if you start out at minus 4 on the number line and go 2 units to the left, you'll get a minus 6. All right. How about 4 minus a minus 2? Well, when you subtract a number, it's like adding the opposite of that number. So I could rewrite this as 4 plus. Well, what's the opposite of negative 2? The opposite of negative 2 is positive 2. All right, I think all of us would start from here and go right to here. A negative of a negative is a positive. So 4 plus 2 is equal to 6. Of course, 7 minus minus 5, and again, negative of a negative is positive, and 7 plus 5 is 12. Minus 15 minus minus 12, well, again, negative of a negative is positive 12, so minus 15 plus 12 gives me a minus 3. 5 minus 5, if you subtract a number from itself, of course, you get a return of 0. 0 is what they call the arithmetic identity for that reason. All right, let me get a fresh screen here, and we'll do some fractions. Subtracting some fractions. All right, so let me write that down here. Subtracting or subtraction of fractions. And the same idea holds. We'll still need common denominators, etc. But if I've got, well, let's see, this is example 10 in our text on page 53, if you want to look along. We've got 5 ninths minus 13 fifteenths. All right, and similarly here, if you're subtracting a fraction from another, it's equivalent to adding the opposite. So I can say it's 5 ninths plus the negative of 13 fifteenths. All right, we still need a common denominator to add these fractions. If I look here, try something new here. All right, 9 and 15, right? What's the least common denominator of 9 and 15? I'm thinking it's 45. Let me write that down. LCD is 45. If you notice, 9 times 5 is 45. And 15 times 3 is also 45. So 45 is a multiple of both 9 and 15, and it's the smallest number that's a multiple of both. hence the name common denominator. Let me clean some things up here. All right, so we want to express these two fractions with my LCD as denominator. The LCD is 45, so I'm going to multiply in this first fraction top and bottom by 5, right? Let me put that in green. Multiply top and bottom by the same value to maintain equivalence. So upstairs in this first fraction, I'm going to get 25 over 45. Similarly, in the second fraction here, I'm going to multiply top and bottom by 3. 15 times 3 is 45, and I'll get a minus 39 on top in that second fraction, right? All right, now I can add or subtract the numerators as indicated. I'll say 25 plus minus 39 is going to be the sum of my numerators divided by my common denominator. And 25 plus minus 39 gives me a negative residue, negative 14 over 45. Let me put a box around that. Circle that answer, minus 14 over 45. All right. Let's see, you can do another example from the text. This is example 11 on page 53. All right, they write this out in words here. Don't get thrown, don't panic, it's not a word problem. Subtract minus 7/18 from minus 9/15. All right, you're subtracting one number from another. So that means I'm going to start out with minus 9/15, and I'm going to subtract minus 7/18. So a lot of negative signs floating around here. So with some good housekeeping, I think we'll be okay. All right, again, the formal definition of subtraction says if you're subtracting a number, you're adding the opposite of that number. So, or again, a little more informally, I could say the negative of a negative is a positive. So it's equivalent here to taking minus 9/15 and adding 7/18. And it's just like a problem we did in section 1.6, our previous section. All right, we're going to have to think for a minute here. (15) and 18. What is the least common multiple or the least common denominator of 15 and 18? I'm thinking it's 90. Let me write that down. LCD 90. 90 is 15 times 6. So it's a multiple of 15. 90 is also 18 times 5. You check that. 5 times 18, yes, 90, that's right. So we can see 90 is a multiple of both 15 and 18, and it's the smallest number that's a multiple of both, hence the name common denominator. All right, so I'm going to want to convert these fractions to equivalent fractions with 90 as my new denominator. Watch out for the signs here. I'm going to multiply, let me get another color here. Top and bottom, this first fraction, I'm going to multiply top and bottom by 6, because 6 times 15 is 90, right? So in the numerator, I'll end up with a minus 94, my adjusted numerator. Over here in the second fraction, if I multiply 18 by 5, we know 18 times 5 is 90. And upstairs, maintaining equivalence, 7 times 5 is 35. All right, so I've equivalently expressed fractions with my new common denominator of 90, and I can now add or subtract the numerators as indicated in keeping my common denominator. So 90 is going to be my denominator, my common denominator, and upstairs minus 54 plus 35 Looks like minus 19 to me. So I'll write it minus 19/90ths. And that can't be reduced. 90 is a prime number, and 90 is not a multiple of 19, so there's no common factors to simplify here. All right, that was example 11 in the book. Let's try another one. Example 16 I want to do. I'm sorry, example 17 on page 56. Let's see, minus 3/5 minus 7/8. Again, we're asked to subtract one fraction from another. When you subtract a fraction, it's equivalent to adding the opposite. So I suppose I could rewrite this in this fashion if you like. All right, I believe the LCD, the least common denominator of 5 and 8 is 40, is it not? 40 is 8 times 5, and 40 is also, of course, 5 times 8. So I'm going to express both these fractions equivalently. With 40 as my new denominator, I will multiply in the first fraction, multiply top and bottom here by 8. Let me get a new color here. Well, that, of course, is going to be 40 in my denominator, and minus 3 times 8 in the numerator is going to be minus 24. In the second fraction here, I'll multiply top and bottom by 5. Again, you want to end up with 40 as a denominator. Your adjusted numerator is then going to be minus 35. And, of course, I will then add or subtract my numerators as indicated. I'll get minus 24 plus minus 35 over 40, and that gives me a return of minus 59 over 40. Okay, final answer. Again, no mixed numbers, please. If you have an improper fraction, meaning the magnitude of your numerator is greater than the magnitude of your denominator, that's fine. Just make sure your final answer is simplified. No mixed numbers, please. With more than two values being added and or subtracted. Something like this. This is example 18 on page 56 in our text. There's an A, B, C. Let's look at A first. Example A says this, 9 minus 12 plus 3. Well, which do you do first, the subtraction or the addition? When you've got a chain of commands here like this, if all you're doing is adding and subtracting, then we go left to right. If you're within this window here, just addition, just subtraction, we go in order from left to right. So by agreement, we'll do 9 minus 12 first, and 9 minus 12 is, of course, minus 3. Then I'll do the addition, and minus 3 plus 3 is, of course, 0. That's part A of example 18. Let's look at part B. Minus 7, minus 15, minus 6. All right. Well, let's see. Again, it's all addition and subtraction here. This gets done first. Left to right, if all we're doing is adding and or subtracting. So minus 7 minus 15 is, of course, minus 22. And then we'll do the second one here. Minus 22 minus 6 is, of course, minus 28. Okay. Part C. Example 18, page 56, part C. Minus 5 plus 1 minus 8. And this is the one that gets done first. And minus 5 plus 1 is minus 4, and minus 4 then minus 8 is minus 12. All right, two more I want to do here. The two homework problems. Let's see, homework. This is number 113 on page 58. It's one of the last ones in your homework list. I suppose if you can do something like this, you can do all of these. And the homework assignment, minus 9 minus minus 3 plus 4. All right, of course, this is the operation that gets done first. We're just doing addition and subtraction, and when you're restricted to those two operations, then yes, you do go in order from left to right. All right, so minus 9 minus minus 3. Well, a negative of a negative is positive, so I'll just take minus 9 and add 3, and of course I get a minus 6. Then I'll worry about the second one down the line. Minus 6 plus 4 is, of course, minus 2. All right. Oh. Hang on, I'm scrolling out of control here. All right, last one. Homework. This is number 117 on page 58. 17 plus minus 8 minus positive 14. All right, really this positive sign here is somewhat redundant, but we'll leave it there. I believe this is how the author wrote it. Let me make it a little more clear. All right. All right, so we've got three numbers here. We've got to add an addition and then a subtraction. Of course, we'll do this first in order from left to right. 17 plus minus 8 is, of course, positive 9. And then 9 minus positive 14, well, that's just 9 minus 14, isn't it? Or I could write it as 9 plus the negative of 14. Don't want to get too fancy here. And plus 9 minus 14 is going to return me a negative 5. All right, so this concludes section 1.7, subtracting real numbers.